Now we are going to use our software. We are mainly using Logisim software, so you can download your Logisim software by simple search in Google, write Logisim and click here and download from here. This is an free version of Logisim software, and this is the portable software, so use this. So let's start. So I have already downloaded Logisim software, so click here, double click. So this is our Logisim software. If you see here, then you will see some cursor. So this square uh, square symbol is used for input, get input, and this circle is used for output. And this is our different software option. So we need this folder, that means gates folder. If you click here, then you will find all your gate, lots of gate here. So our main target today is the universality of universal gate. So let's start. So I need firstly I need NAND gate. So use this gate. If you click here, then you will get here description of this gate. So there are mainly 5 inputs in this gate, but we need only 2 number of inputs. That's why we change this input to 2. So you see here we have only 2 input. So first of all, we are going to develop NOT gate using only NAND gate. So how can we develop this or implement this? Just create your wire by using your mouse and short this two wire and another wire and click here for your input. So this is our input. Click it and connect this. And this is your output, so need your output symbol and connect it. So use your hand tool. Let's use the hand tool. By using this hand tool, you can change your voltage. You see that your input is now 0 and output 1, but if you give input 1, just click it and your output is 0. That means this gate behave like the NOT gate and like a sine inverter. That means if your input is 1, output is 0, input is 0, then output is 1. So this is the NOT gate, the implementation of NOT gate using only NAND gate. So you can also label here by using this tool. So just A and another is A bar. So just use wire click here base ring tool, you can mention here, that means labeling here. So your input is A and output is A bar. Now I am going to show you and get implementation of AND gate using only NAND gate. To implementation of AND gate, you need two NAND gates. So find NAND gate from here and click NAND gate. You need two NAND gate. Two NAND gate. Label here. Just decrease your input. Two input and two input. So your input is A and B. Get your wire. Select your input and connect with wire. This is your output. So and this output will be input for this NAND gate. So create NOT gate by using only NAND gate. Just short the wire or connect the wire, and then output this output connect this gate. Select output and connect with wire, and select hand tool. Looks, if your two input is 0 0, then you will find output 0. If your one input is 1, then your also output is 0. If your two input is 1, then finally you will output is 1. So this behavior like AND gate. So this is the implementation of AND gate using only NAND gate. Now we are going to create OR gate using only NAND gate. So now we are going to implementation of OR gate using only NAND gate. So in this case you need 3 NAND gate for developing OR gate using only NAND gate. So let's start. Select NAND gate. So first NAND gate, second NAND gate, and use third NAND gate. Because there are number of inputs, too. So connect the wire and short this. So these two are used as a NOT gate of NAND gate. So this is our input symbol. Connect it with this input symbol. Connect it, and this two NOT gate output will be connected with another NAND gate. So connect it. Also connect it. Connect with your output symbol. Just connect it. So select your hand tool. Looks there, if your input is 0 0, then output is 0. If you get 1, if your input is 1, then you will find the output 1. If your two input is 1, then you will find the output 1. If your two input is 0 0, then you will get the output 0. So this behavior like the OR gate. So this is the OR gate, implementation of OR gate using only NAND gate. So this is the prove the universality of NAND gate. So save it from file and save as. So I save it in my desktop. Just name it and universality proof NAND. So this is so I already saved this. So this is our circuit. So another universal gate is called NOR gate. So we are going to now prove the universality of NOR gate. So click file, new. So click the gates. Just use NOR gate. So I'm now going to show you implementation of NOR gate using only NOR gate. So click here and decrease your input to and short it. Just click and select input symbol and connect it, and also select the output symbol and connect it. So this is the NOT gate using only NAND gate. Let's check. Select your hand tool. If your input is 0, output is 1. If your input is 1, then output is 0. So now I am going to show you an AND gate implementation of AND gate using only NOR gate. So to develop the basic gates of AND gate using only OR gate, you need 3 NOR gate. So use NOR gate 3. Let's decrease the number of inputs of NOR gate. Just connect your wire. That means short your wire. Okay. Use your input symbol. Connect it. Use your input symbol. Just connect it. And connect it. Also connect it. Use your output connection and connect with this wire. So this is the AND gate using only NAND gate. Let's check. So if your input is 0, 0, then output is 0. If your input is 1, input is 1, then output is 0. If your 2 input is 1, then finally you will get the output is 1, which is behavior like the AND gate. So this is the implementation of AND gate using only OR gate. So now we are going to do implementation of OR gate using only NOR gate. So to develop the OR gate using only NOR gate, you need only 2 NOR gate. So use 2 NOR gate. One is here here is, yeah, decrease their number of inputs to decrease their number of inputs to. So connect the wire and short it to wire, and this output connect with this wire and use to input symbol and connect it. Use the output symbol. So this is the OR gate using only NAND gate. So let's check. Use your hand tool. Click here. If your input is 0 0, then output is 0. If your one input is 1, that will be that output will be 1. If your two input is 1 1, that means high voltage, then you will also output, you will find the output also high. So this behavior like the OR gate. So this is the implementation of OR gate using only an OR gate. So this is the proof of universality of NOR gate and NAND gate. So see you next one. Until, good luck. Allah.